I have 3 really cool presentations to show you guys. The first one is from Regent. All of them are from the CEOs of the company. The second is from Light Aviation, and then Jump Aero. Maybe you've heard of these companies, maybe you haven't. They're all eVTOL companies doing completely different things, going after very niche markets, and I think they're all really cool, and they're all really legit. They're all in my eVTOL conference, if you may have seen it live. I know most of you are probably watching because you're in HOVR and you're not that interested in these companies. In fact, you can't even invest because they're all private. But it's still really important to know what the other companies are doing and also just get the bigger picture. Like, I really like this presentation because this lady doesn't even talk about her plane. I mean, honestly, I don't even believe in it too much. It looks just like a regular aircraft, just with this, eVTOL aspect. And it's going after a specific use case. It's 40 passenger plane, but I don't even like her airplane that much. I just like her presentation because it talks about, the history and, certification and, regulation and all sorts of things with eVTOL as an industry rather than her actual company. Regent talks about their aircraft, and I just think it's one of the coolest looking aircrafts. Also, it's going their website's super cool. Also, shout out to them because they are on Webflow, and I'm a Webflow developer. I love Webflow, and their website's actually really cool. I really like how they have it laid out. They're telling you all their categories. They're going after cargo, tourism, and they're even showing you the interior. Oh my God, look at that. You can have like a surfboard and go out in the water. That's so cool. Look at this one. This is so cool. Search and rescue. This is an interesting use case that I don't see anyone doing. I know HOVR could be amphibious, but the aircraft is not large enough to really maybe like rescue. Imagine like a plane wreck in the water. Like there's probably hundreds of people. They need to send out like, I don't know, multiple of these, right? This seems more legit to me than HOVR landing in the water and doing that. I don't know what they could do with defense. Okay, carry some cargo and stuff. But I really like their website, how they lay out like how easy it is to understand what they're doing. I wish New Horizon Aircraft did something like this. This is in Webflow. I could do something like this for them if you're watching this, Brandon, and want something like this. Honestly, this is super cool. I mean, you guys can do this yourself. But just as a suggestion, like I like this as like a kind of like a industry leading website as an eVTOL company. But I want to get to the presentations. You can also just skip to them if you're not interested in me talking too much. I just wanted to go over their websites before I show you their presentations. They're going to show you all this in the presentation. In fact, this presentation talks all about their aircraft, and then so does Jump Aero, so I don't even want to show you too much because also all the images are going to be on the presentation, so you're going to learn about them. I just think they're an interesting use case because I actually really like this guy's presentation. The way he talks and, just how he outlined the whole presentation. After seeing hours and hours of all the eVTOL presentations, there's been some really bad ones, and you could tell they're really legit. Like these, also the founders are really cool. Like have a really cool background, and they're all really legit. Like there's some people there's like freaking random African people who were on there, couldn't understand Indian people. There was literally an AI presentation. Someone didn't even show up and just made a presentation using AI. Like, those companies are not legit. These companies, the CEOs showed up and, gave their presentation, and they give a good presentation. They have slideshows. So respect to them. I like them. I want to just, highlight these because I think they might be, winners in their categories. And something that I want to just highlight is there's not going to be one winner takes all in this industry. There's probably going to be like, one winner in every category because there's all sorts of interesting use cases. It's not like, building a car where you just, you have one type of car even cars, right? There's buses, there's trucks, there's semi-trucks, there's, I don't know what, like so many different categories of transportation, right? So, we all know the big car companies, but like there's also big trucking companies that we don't even know about. I can't even name you the names. I'm sure some of you guys know, but all I can think of like is Isuzu or something like that. I don't know, whatever. But the point is, there's going to be winners in every category, and these are really interesting. I'm talking too much. Let's just jump into the presentations. I'm going with this one first because this is big picture. This one, I just really like his presentation. I also reached out to the CEO. I want to get on an interview with him and possibly post that if he's interested, but he hasn't reached back out yet, so we'll see if that happens. And then this one, I just really love their aircraft. So this is last to show you, and this is probably in the thumbnail just to get you hooked. So also to get you staying, it's going to be in the end. But yeah, those two kind of just talk about their presentation. I mean, their aircraft, and this one I like as big pictures. So enjoy that. And yeah, also she's actually really cool. She's was the founder and CEO of an OEM company. She mentions it real briefly, so you might forget that. But I want to just highlight that, like, she kind of knows what she's talking about. So I really like her presentation, and enjoy.
Thank you, Gary. Hi everyone. Good evening. Philip, also thank you very much for mentioning us. Yes, light aviation. And thanks for the kind introduction, Gary. I really appreciate it, and it's really a pleasure participating today. And yeah, I thought I'd just speak about a different kind of topic. I think it's just, I guess I got inspired when I read some of the headlines that someone forwarded to me, an article the other day. I thought maybe we should just talk about that elephant in the room, certification. So, first of all, I'm CEO and founder of Light Aviation. And Light Aviation, we're working on building the first 40-seater hybrid hydrogen eVTOL. We're based in the UK, but my team currently we're in Germany. So yeah, so let me just maybe start giving you the perspective, our perspective on certification. So the way I see it is, give me one second, sorry. So okay. So yeah, it's the elephant in the room. It's certification. Yes, it's real, it's hard, it's heavy. And lately, as I mentioned before, the headlines are raising the flags about whether eVTOLs will ever get certified. So that is a big question. Understandable. And I personally, as CEO and founder of an OEM manufacturing company, yes, I welcome these questions. I welcome these concerns because we need these questions. We need to face these challenges head on, but also we need to zoom out, way out sometimes, and look at it from a different perspective. And like you mentioned, Gary, as well, like one of my inspirations back then when we were researching was also the ferry Rotodyne in the UK in the 1960s. So if we were already like mapping out the routes back then, why can we not do it 70 years later with so much more advanced technology? So that was my base thought. So this is sorry, one second. The challenges. So it's true. So what are the eVTOL certification challenges? So mainly, as Philip also like mentioned it, like so it's also the resources from the regulators the site, but also technically um, th- yes, they're reflecting some doubts, some worries, even the disillusionment around the certification of eVTOLs, especially the air taxis, the two-seater air taxis. The concerns are valid, too many rotors, too much novelty, battery inefficiency, transition modes, and of course, regulators playing catch up. But I invite us all to take a deep breath here because, and then look at this from a higher altitude. Um, because when the first, so when we look at the history of disruption, aviation 1.0 versus 2.0 now with the air taxis, when the first airplanes flew, regulations didn't even exist. So governments scrambled to invent them. Engineers broke every rule in the book because the book hadn't been written yet. But that didn't stop anyone. That didn't stop anyone, and it won't stop us either. Everyone that's working right now on the drones and the eVTOLs, that won't stop us. So it is a matter to definitely consider the certifications, but it will not stop us. And so the challenge here, for example, for me was as well, I mean, it was not a challenge, but it was interesting to see. The first reaction before I actually announced my project, the first 40-seater eVTOL, I actually mentioned it to a lady that's very well established in the aviation industry. And the first thing she said, Freshta, but you know, you're tapping into one of the most highly regulated industries on the planet. And I said, I know, and I'm not, but I know it's doable. And if I was afraid of certification, I wouldn't be here, which means light aviation has been rising since 2020. So we received 23 pre-orders for our aircraft worth 920 million already. We have 5 more pre-orders in the pipeline, working currently on 19 different projects on 4 continents, and we're tapping into a $474 billion market. So, and why we will certify? Hopefully, yes, with the optimistic perspective that we have, because we try to design it from day one accordingly, considering the certification. So even 5 years ago, we knew certification would be the wall every visionary would hit, because we studied, we took the weaknesses and the strengths of every eVTOL that was out there in the market, to understand how can we actually make sure that we get certified. So we asked ourselves, how do we fly with it, not into it? And everything that was designed basically around these 2 basic questions. Can we take off with 40 passengers or 4.5 ton cargo vertically and cruise? The answer is yes. And can we get it certified? Yes, eventually. That is the hope. So because we have chosen intentionally design particles, basically like the 4 large turboprops that are proven, they're certified, where we have chosen 4 electric engines, we have chosen hydrogen fuel cells, but also the tilt wing architecture that's already proven in military. So, and then the importance of the two-seater air taxis. They have been now around the last, let's say, the last decade. They were a personal inspiration for me as well, for my journey. Um, and if I see a Joby or an Archer taking off, I'm thrilled. I'm really absolutely excited, because they're paving the way. We are the next scale up with a 40-seater. But when I see them actually operating or doing their test flights, so they're already 10 years or 5 years ahead of us in testing. They're helping regulators as well learn what works and what doesn't. So EASA, for example, has already defined some of the regulatory path for hybrid electric VTOL aircraft with passenger seating via its SC-VTOL framework. So this is just one simple example that regulation is moving forward. So it's not stagnating, it is happening. There is a lot of work that's being done by the regulators, whether it's in Europe or in the US with the FAA, or even others in the UK as well, and the GCAA. Everyone's working on it because they know it is inevitable. It's happening. So what I like to what I like to compare it with is I think sometimes visionaries is hard to understand maybe the vision, but once we actually look back and see how visionaries have actually established their successes, is one of them was the BlackBerry moment, for example. When the BlackBerry launched, mobile networks said we can only handle 500,000 users, and that's it, no more. So it was limited. Everyone thought that was the limit. But the engineers kept going. They expanded the networks, and then came the iPhone. Suddenly, mobile internet was limitless. Why? Because one crazy team believed the limit was just a starting point. And that's where we're now. BlackBerry was first. The iPhone moment is coming now for our eVTOLs. Just like with eVTOLs, the challenge isn't whether they fly, but whether systems and the entire infrastructure can as well grow with them. And yes, also for us, we have our challenges, big ones. We have a 40-seater, which has a length of almost 20 meters and 19-meter wingspan. So we have our own challenges, and especially we have a larger range of up to 1,000 kilometers. So we're not flying rooftop to rooftop like the air taxis are planning. I mean, we're planning back then, but we're flying city to city, region to region. So we have completely different challenges here. And so yes, the use cases, they're challenging, but they're lucrative. The benefits, they're challenging, but they're lucrative. And the partnerships, they're challenging but lucrative. But our infrastructures, the partners that we have in general, the suppliers and our infrastructure partners, they believe in us. Our investors, they believe in us. Our customers, the airlines, they believe in us. The aviation industry, they believe in us. They're seeing what is happening. So I think it's just a dance now. So the last decade, I think we're all dancing to the same rhythm and the same, and we're looking all into to the same direction. And so yeah, the bigger picture here is eVTOLs are currently at this state, 2025, still somewhere partially for visionaries. So eVTOLs are not for everyone yet, because there are those who see 10, 15, 30 years ahead. But if you only see today, that's okay. But then it may be hard to understand what we're building for the future, because we're not just building an aircraft, we're building a future movement system here. So for us, it's not if, it's not even when, it's just how fast and how smooth can we align with the entire ecosystem. And so the way we see certification is not a wall, it's a mirror. Certification is not our enemy, it's our greatest ally. We need certifications in order to make sure that we have safe aircraft. It reflects, but also it reflects how serious we are. We've already started early talks with regulators. We're not waiting for permission. We're inviting them to the table now because we want to build this industry together with the regulators, but also with our partners and suppliers. So yeah, and then again, from our perspective, from vision to reality, I know for some it's difficult maybe sometimes to see that the power that's behind it, but we're not naive, we're not reckless, we're not idealists, but we're realists with vision, and we're engineers with imagination, and we're founders with fuel, and we will fly. Not because it's easy, but because it's necessary. Because this time, the sky isn't the limit. So we're living in great times, whereas the sky is just really the beginning. And so, yes, we do believe that believers create the future. So when I, again, like when I see the two-seater air taxis advancing, but also with their certifications that were also mentioned before, this is proof for us that something is moving at least forward. So when we will all get certified, it's probably not clear, yes, but we have a rough estimate to know where this journey is going and when we roughly will get into operations. So, so when yeah, basically when I see the two or four-seater air taxis, for me personally, they're the proof that the path is opening. And so, bup, bup, bup. Yeah, and that's why I had to speak about certification today, because I think when I again when I read those headlines, is it even certifiable? Is it even happening? I think it was for me personally then important to maybe just round up the image here, to also look at it from our perspective, that that's because the conversation is not just about airframes and engines, it's about really about mindsets as well. In aviation, we have all kinds of perspectives that are essential to our overall success. So we need the visionaries, we need the regulators, we need the technicians, the pilots, the investors, the infrastructure builders, the suppliers. We need every single one of them. But never forget, without the visionaries, we wouldn't have smartphones, we wouldn't have cars, and we sure as hell wouldn't have airplanes. Yes, pilots are in shortage, certifications are difficult. Yes, infrastructure is missing for air taxis, but we're all building ahead of time. We're going step by step into the same direction, and we're working on it. So because we know we will need an entire ecosystem moving towards that. So yes, certification, one way or another, it will happen. That's it for me. Thank you so much for listening. And yeah, this is me basically. If you want to get in touch with me, thank you so much.
Thank you, Fresta. It was really good listening to you. And
we're going to go straight to Carl with his presentation. And the floor is yours, Carl. Thank you for your message.
Hi, it's a pleasure to be here. So yeah, I appreciate the opportunity and the rejuggling of the schedule. I'm gonna share my screen here. So as was mentioned, my name is Carl Dietrich. I'm the founder and CEO of Jump Aero. Uh, Jump Aero is developing an eVTOL specifically for rapid response missions to help first responders get to the scene of rural emergencies as fast as possible. Um, it turns out that, and I'm going to be presenting data that's mostly from the United States because that's where we have the access to the best specific data. But in the United States, the average emergency response time in rural areas is about 14 and a half minutes. It's about twice as long as what it is in urban or suburban areas. And that 7-minute difference, it doesn't sound like very much, but it can have a huge impact on patient outcomes. For example, in a case of cardiac arrest or pulmonary issues, stroke, severe trauma, car crashes, things like that, if oxygenated blood stops getting to your brain, you're on the clock. And within the first few minutes, you're going to lose consciousness. If you can get oxygen restored to your brain within the first 7 to 10 minutes, you've got a shot. Beyond 10 minutes, we're talking about coma, brain damage, and by the time you're out at 15 minutes, survival is nearly impossible. So what we have right now in the United States, in arguably a first world country, we have a situation where the average response time in rural areas is one where you're going to die if you have a cardiac arrest and you don't have somebody there who knows what they're doing and can reestablish the flow of oxygen to your brain. With eVTOL technology, we can change that. We can bring emergency response times on par to what we have in cities. And that's the opportunity that we saw at Jump Aero back in 2019 when we got the company, when we founded the company, is this opportunity to shave just a few very critical minutes off of rural response times and help save a lot of lives. The data is pretty astounding when you dig into it. These are just 4 time-critical emergency cases: stroke, heart disease, respiratory failure, and then just severe trauma or injury. In these cases, and these data compare percent deaths preventable for rural areas and then in metropolitan areas. So, and you can see across the board for all of these cases, you've got double-digit percentage differences in percent preventable deaths for all of these time-critical emergencies across the board between rural and metropolitan areas. So just that difference from 14 and a half minutes down to about 7 minutes response time means a huge, huge number of lives saved. In fact, we dug into the numbers and we've made some estimates. And we believe that just in the US, we're talking about 67,000 lives per year. If we look globally, because there is so much of a larger rural population across the world, particularly in developing nations, there's the opportunity to save on the order of 3 million lives every year just by getting this eVTOL technology out across the globe in this first response capacity. So that is the founding mission of Jump Aero, is to try to leverage eVTOL technology to get out and save lives. To do that, we've developed a specific aircraft that meets the requirements of first responders and the need to fly very quickly, deploy quickly, fly quickly, and land close to the emergency with life-saving equipment. So this is the JA1 Pulse eVTOL aircraft. It is different from basically any other eVTOL that you'll see out there for a variety of reasons. One, you notice it's a standing tail sitter vehicle, so it doesn't have any tilting pods. The whole aircraft tilts over to fly very, very quickly. It has a very low frontal area, enabling high dash speeds. while at the same time not adding the complexity of tilting pods and things of that nature. The vehicle is designed to fly at speeds up to 250 knots, so significantly faster than eVTOLs that are optimized for air taxi missions. It turns out if you want to optimize a vehicle for an air taxi mission, you actually want to fly a little bit slower to conserve energy, reduce your power demand. In this application, because every minute is so critical, it makes sense to invest in a faster eVTOL aircraft. And so we are right up against the speed limit under 10,000 feet, right at 250 knots, which it turns out is also the maximum speed that is allowed under the newly published Modernization of Special Airworthiness Certificates, the MOSAIC light sport aircraft rulemaking. So that rule just went live last week. It's incredibly exciting news. And Jump Aero's JA1 Pulse eVTOL is designed to be fully MOSAIC compliant. So in the United States, will be classified as a light sport aircraft. What that means is that we will meet international industry consensus standards, ASTM standards, that the FAA accepts as being reasonable means of compliance to the new Federal Aviation Regulation Part 22. And those standards are being written by the ASTM committees, Committee F-37 in particular, of which Jump Aero is a member. We are very active in helping form those standards that are based off of the standards that the FAA is already accepting for certified eVTOL aircraft. So it's a robust framework. It doesn't reduce the requirements, the engineering requirements on these aircraft, but it does provide a compliance pathway that is more akin to light sport aircraft as opposed to traditional, or what we're calling traditional now, 2117B special certification project or special type certification project. So under this new construct, the JA1 Pulse will not have a type certificate per se. It will get an airworthiness certificate that is an SLSA airworthiness certificate, akin to other special light sport aircraft that are in the field today. So why does this speed matter so much? Well, it turns out when you look at this particular use case, the economics of the business model are driven by how many people can you cover in the time-critical 8-minute response window with one aircraft and a team of 2 people on duty. And that drives you to a dash-optimized design. With the JA1 Pulse, our 250-knot dash speed enables us to cover about 3,000 square miles with one aircraft and a 2-person team. And that 3,000 square mile coverage area can afford you a very low average population density to have an economically viable operation. So it's a big, big difference. So if you try to take an aircraft that is not specifically designed for this mission, not specifically designed for the high dash speed, much slower speed, your radius is much smaller, and as a consequence, the number of people that you can cover with one aircraft is much smaller. So this vehicle is really the only vehicle that was designed from the ground up for this particular mission, optimizing for this, how many people can you get to in 8 minutes? Key figure of merit. So we went out and we surveyed over 500 rural Americans, and it turns out if you live in a rural community, you know that it's going to take a long time to get help if you need it, if you call for help. And so we asked them what they would be willing to pay on top of what the taxes that they already pay today to have this new type of service available. And it turns out, there's about 21% that are not interested, but a full 79% of those surveyed are willing to pay something extra. And 33% are willing to pay more than $2 a day. 55% are willing to pay more than $1 a day. So what that represents in that $1 to $2 a day is a $13 billion a year greenfield market opportunity for a subscription service to get this technology out there as quickly as possible. And that's what you need, is you need the economic motivator to get it out there, to prove that this can be a life-saving technology and get it out as fast as possible. In other words, we leverage the capitalistic forces to get that technology out there because there's money to be made. And then once people see that, oh yeah, this really works, then it's very likely that, since we've got 79% of the population that are willing to pay something for it, that we will be able to, in the long run, this will be a taxpayer subsidized service that will just be available to everyone. But in the near term, you've got a great motivator because there's tremendous money to be made in the space. So our launch customer is Falck. This is one of the largest global emergency response companies in the world. They operate out of 24 countries, including the United States. They do over 9 million EMS operations every year. And they've already reserved a number of aircraft and plan on deploying them in targeted locations around the world, starting in the United States. Beyond that, we have MOUs in place at both the state level, the county level, and with tribal governments to deploy this technology in trial operations and show, we'll learn together what the actual real world operating costs of the aircraft are. And we plan on just publishing that information freely so that everybody can make informed decisions about how to best deploy the technology. So where are we today? We've been flying subscale drones for the past 5 years. We now are flying what we call dynamically scaled models, so real true subscale aircraft of our full-scale aircraft that are flown on the same flight computer as will be flown on the full-scale aircraft. And our full-scale prototype, our first full-scale prototype, is under construction, partially subsidized by an Air Force contract. That full-scale aircraft, we have all the parts for the inner pods, the outer pods built. We have all the tooling made for the upper wing. The lower wing tooling is under construction, and the fuselage tooling is going to start within the next couple months here. So it's a very exciting time. By this time next year, we expect to have a full-scale prototype starting to get ready for its first bunny hop. So extremely exciting time at Jump Aero. This year, we actually already completed our first dynamically scaled transition of our subscale aircraft using the same flight control laws that we'll be using on the first full-scale aircraft. We're targeting a first flight of that full-scale proof of concept next year, and then hopefully moving into piloted flights in the 2027 timeframe, with the goal of deploying this aircraft in these trial operations as soon as possible in 2028, and ideally saving our first life around that time. So that's our goal at Jump Aero, is to get to our first life saved milestone as quickly as possible, and then expand production and get this product all around the world as quickly as we can to start saving lives. So with that, I'll wrap up my presentation, and really appreciate your time and your interest, and the Advanced Air Mobility Institute here for providing a forum from which to share our message about the opportunity to leverage eVTOL technology to help save lives all around the world. Thank you.
Hey, good afternoon, everyone. Adam Triolo from Regent Craft. Hope you're well. Wanted to orient you over the next 20 minutes or so with Regent, who we are as a business, and how we're tracking toward first flight of our full-scale prototype. Regent builds all-electric wing and ground effect seagoing vessels called seagliders. They are meant to solve a number of challenges associated with existing modes of transportation. So whether it's long lines at the airport, expensive airfare, uncomfortable rides on ferries, or sitting in traffic, we wanted to come up with a whole new way of moving people at much lower cost. So our two co-founders, Billy Tallheimer and Mike Klinker, both have advanced degrees from MIT and worked in aerospace. Our chief designer, Brian Baker, was Team Oracle America's Cup and knows everything about foiling boats. And they sought out to design this vessel that actually travels in ground effect. So what is ground effect? It's the compression of air beneath the wing surface when you're traveling at speed. So you can actually experience ground effect every time you take off or land in an airplane. So as the aircraft gets within a wingspan to the surface, it actually compresses the air, diminishes the wingtip vortices, and travels with a 10 to 15% reduction in drag. So 10 to 15% efficiency gain. So we leverage that space exclusively. Our vessel flies at about 30 feet above the water. And in doing that, we can carry larger payloads further distances at lower power settings. But by never leaving ground effect, we can certify this vessel as a boat instead of as an aircraft. Interestingly enough, seagliders combine a number of previously existing technologies in a novel way. So we use an active control hydrofoil to maneuver through the water. So this hydrofoil is T-shaped. It extends into the water and allows us to elevate the boat up out of that heavy hydrodynamic drag and provide a much smoother ride for Seaglider customers. As I mentioned earlier, we use ground effect for more efficient flight. And then we use our blown wing. So by distributing the propulsion across the leading edge of the wing, that allows us to get airborne at a much lower airspeed than a conventional seaplane, for instance. So we blow that wing, and that reduces our takeoff speed from about 80 knots to 45 knots. And that allows us to take advantage of those much smoother rides achieved by actually being in flight. Finally, we provide this novel control interface. So while this vessel floats, foils, and flies, there is no pitch control allotted to the operator. You drive
Recording in progress.
Left, right, fast, slow. There are a number of thrust lever gates. As you push up the thrust, just like you would on a conventional boat, you'll move between gates from float mode to foil mode to fly mode. Once it reaches a sufficient speed, it takes off automatically, and that's where it cruises. When you're ready to slow down, you pull back on the power lever just like you would on any other boat, and it'll enter an auto land sequence and land. So as I mentioned, the vessel operates in 3 modes. When we're near the dock and in the no-wake zone, we float on our hull. When we proceed away from the dock and into the busy harbor, we rise up onto our hydrofoil. And then once clear of the busy harbor, we come up onto our wing. Obviously, that wing mode is where we can reach those much higher speeds, so about 160 knots. But what's important to note, and one of the things that people often ask is, how are you going to manage navigating traffic in busy harbors when you're going 160 knots? And the answer is we won't be going those speeds in congested spaces. So the 3 modes of operation allow us to really expand the operational envelope of the vessel itself. So when it is super congested or we're in a no-wake zone, we can just float on our hull, just like any other conventional boat. But if we wanted to do the whole mission at that 50 knot range and below, we could on hydrofoils. So these vessels are really unique in that we can use them for inland waterways. We can use them for river navigation, and anything else you would do with a hydrofoiling boat, you can do with a Seaglider. You do not have to take off. But of course, if you want to take advantage of the range, if you want to take advantage of the speed, you need to take off, and our customers will accomplish that, off the coast once they're clear of the congested spaces. So as I mentioned, Seagliders are boats, in this case, flying boats. But because we never leave a wingspan to the water surface, we certify under maritime law. So you can see a depiction. We're actually about half the height. We cruise at about half the height of a traditional sailboat, well below that of a traditional cruise ship, and exponentially lower than you would find with a helicopter or an aircraft. So, the sensation will be that of, flying very, very low over the water surface, almost like high-speed rail feels. were really meant to operate in conjunction with all of the other existing modes of transportation. So where seagliders will accomplish that regional mission, sub 200 statute miles, we will partner with eVTOLs once we arrive at airports or ports to move people into the city centers. So this is not meant to be a wholesale replacement. We'll only operate these vessels over water. They do not travel over land, but we can share infrastructure. So we can use the same charging required for a Naviair or a Candela or an Artemis hydrofoiling boat. We can use the same charging infrastructure as you would find on Beta. Lots of nice synergies there. But what's important to remember too is that these vessels can leverage the same places. So the ports are a perfect location with parking, with power already there. They can also be a great place for takeoff and landings of these eVTOLs. So you hear about some of these, some of these desires to co-locate infrastructure. Seagliders are perfect for that. A little bit about our ecosystem development work. So we're working in a number of places with a number of partners to sort of showcase the way seagliders can work with critical stakeholders to build out infrastructure in different locations. So we're very fortunate to have multiple members of the Seaglider initiatives that help us bring this technology to fruition. I'd be remiss if I didn't talk a little bit about our military traction as well. So we're doing a number of big initiatives. In fact, just a week ago, we announced Regent Defense. So we are a dual-use company. We've been working with the United States Marine Corps Warfighting Lab for the last 4 or 5 years now. And they have been helping us develop seagliders to fulfill the offshore logistics mission. So lots of good things happening there. We're continuing to track as we develop that relationship. We announced a defense-only hybrid version of the Seaglider. We announced the fact that we were moving ahead with our Squire drone project that will be operated by the military Seaglider operators as well. And then finally, we announced a fully autonomous version of the Seaglider for the Marine Corps. We're building these vessels in Rhode Island. So we have 250,000 square feet of facility that's currently in build right there in North Kingston, Rhode Island. Amazing blue economy development in that space. Lots of good things happening as we work together to build out that facility. So we expect the full superstructure to be finished here in the November timeframe. We'll be moving in early spring next year. A little bit about Viceroy Seagliders specifically. This will be our first product to enter commercial service in 2027. Regent is an OEM. So we are just building these vessels the same way Airbus or Boeing build aircraft and sell them to airlines. We build and sell these vessels to various operators around the world. You can see the dimensions here: 65-foot wingspan, 55 feet long. With that much space, we can obviously carry a lot of batteries, but we can also provide a very, very voluminous interior. So this is our standard seating configuration, 6x6. 5 feet wide, 6 feet tall on the cabin. We've got a nicely sized cargo door that's standard on all the vessels. You can see the interiors here in terms of spaciousness and fit out. We offer 34 inches of seat pitch, a 19-inch aisle, and a window about the size of a car door at every single station. But in addition to passenger operations, we've got cargo operations as well. So 5-zone cargo interior can easily carry palletized cargo, JMIC containers, those types of things. We can do combi interiors. We had a number of announcements with some offshore partners, including ADNOC in the Middle East. So lots of good things happening in that space. And then finally, we have a VIP configuration. So similar to what you would find in a private jet or turboprop, this vessel features a double club, an optional side-facing potty. And then for the special mission space, we provide Aero Maritime Patrol, ISR configurations, search and rescue. So a number of ways in which our special mission partners are working to develop these vessels down the road. We announced and have taken orders on our Monarch size vessels. So something important to note about seagliders is that they have this unique ability to really expand, right? So when we talk about derivative product, this is one of the only products in the advanced air mobility space that actually expands or I should say scales up to 50 to 100 passengers. So using seaglider technology that exists today, we can actually get to a regional jet sized product that does the sub 400-mile mission. And what's amazing about that sub 400-mile mission is it's often the least profitable that exists today for airlines around the world. So you can imagine offloading all of those short haul coastal routes from Miami International, from San Francisco, from LA, from Seattle, from LaGuardia, getting all those short haul routes off of these big jets that are taking up landing slots and gate space and moving them to seagliders, leveraging existing port and dock infrastructure. So lots of great opportunities there to really expand the product line and provide new kinds of service. Seagliders, end of day, everybody wants to know, why would you take them? It's really about speed, right? So when you can leverage the speed and the efficiency of an all-electric platform like a Seagliders, you can dramatically reduce the operating cost and therefore dramatically reduce the ticket price on these types of routes. So this is just one example of the ways in which Seagliders can make travel much, much more efficient. That means healthy profit margins for our operators, but it means dramatic time savings for our operators, customers, and all of those people leveraging these vessels. So that's about the whole of my presentation on Seagliders in general. Happy to answer any questions from the audience or talk a little bit about the way the vessels work.
All right, there are a few questions that are coming in. John Martin has a few questions. I think we'll get started with the first one. You mentioned the Seaglider is per definition a boat. Does the Seaglider need to be somewhat certified with aviation authorities or only maritime?
So the vessel will certify only with maritime authorities. Actually, the Coast Guard and the classification societies have everything they need to certify wing and ground effect vessels. Many people don't know that WIGs have been defined under IMO for more than 30 years. And there have been, certification pathways for wing and ground effect under maritime law for 30 years. So everything will sit under the maritime authorities, U.S. Coast Guard in the United States, and we'll be using the classification societies internationally, and we're starting with Lloyd's Register for the first WIG safety cert.
Thank you. We have another question, this time from our moderator, and she's wondering, is there a max wind speed or wave height that would limit operation?
Yeah, so the wave height limitation is defined by both period and height. So there's a graph there that we work off of. End of day, we can go up to 8 feet, depending on the conditions and the period of the wave. We're most restricted at takeoff, but the best way to think about this is we have about 5 times the wave tolerance as a conventional seaplane. So much more wave tolerance than you would find in the existing, modes that are out there. That wave tolerance is created because of our deep V hull, which sort of acts like an icebreaker and slices through the waves. Then our hydrofoil elevates the boat up out of the water. So that gives us, about 5 feet of wave tolerance when we're foiling. And then once we're airborne, of course, we've got sea keeping limitations that impact us. But with this technology and with the wave detection systems on board the vessel, we have this ability to find spaces where the wave heights meet the limitation, land in those spaces, and then transit via hydrofoil as well. So you've got lots of options there. Any other questions?
I think we may have time for just one more, and then we'll go on to our next speaker. This is from Jay Allen, and he was wondering about those seaworthiness and the sea state limits. Do you have more information about that?
Yeah, so we talked a little bit a second ago about the wave height limitations. So seaworthiness sounds a lot like airworthiness. So in this case, you would actually, again, because it's all under maritime law, you'd receive a U.S. Coast Guard certificate of inspection, or that's U.S. domestic deliveries, or you would receive a wing and ground effects safety cert from the classification societies. That effectively deems the vessel seaworthy, and then we help our clients as they receive their flag approvals or U.S. Coast Guard local approvals to carry people for hire. So that's how that works.
And I think we actually might have time for just one more quick one. And there is one that I see in the chat. So is it going to be dual pilot or single pilot? And what are some of the scenarios that might involve a single pilot versus the necessity for two?
So they are not pilots because it's not an airplane. You only operate the vessel in 2 modes, left, right, and fast, slow. So there was 1 boat captain required for this vessel. So single operator by design, but there is the option for a right seater, if you will, and they'll be responsible for helping with docking and passengers and those kinds of things. But that right seater is optional. They are not required to actually run the vessel in any of the modes. There was a question there that came up a couple times about icing conditions. So the vessel is not ice protected. So it will need to operate above the freezing point. We have, some, design advantages as it relates at least to the leading edge of the wing. Those blown spaces are particularly, protected from ice accretion. That said, this is not approved for known icing conditions, nor would we sanction those operations. So that answers that question.
Thank you, Mr. Triolo, for the presentation. We greatly appreciate your insight, and thank you for taking the time out of your busy schedule to come all the way over here. It is such a fascinating technology, and we're looking forward to watching your company's progress. Thank you very much.
Yeah, thank you. Nice meeting everyone.